So thank you everyone for joining us. And a thank you to Terrell for organizing this and for giving us the opportunity to talk to you about our new quantum information science program at the University of Rhode Island in the Department of Physics. So my name is Vanita Srinivasa, and I'm also joined by Leonard Kahn, who's our physics department chair. Our URI symbol is essentially a globe, and I think that's a very good representation of this field. Is really a global field. So a bit about URI, an overview. It's the...
Hey, Vanita, excuse me.
Yep.
Share your screen.
Is it not shared?
Yeah.
Okay. I didn't click the thing. Sorry.
All right. So show us that logo again.
All right. So.
Yep, that looks good. That looks good. Perfect.
There we go.
All right.
Yeah. Sorry about that.
Okay.
Yeah. So it's the global, the world, right, is the logo for URI, and I think it's a good representation for QIS as a field too. So an overview of URI, it's the it's the flagship public research university of the state of Rhode Island. Its main campus, which is where we're also located, is in Kingston, Rhode Island. It has about 17,000 students, and that includes more than 2,000 graduate students. And there are active graduate programs in all of the science, technology, engineering, and math disciplines at URI. So our department is located here in the heart of campus. We have currently 18 graduate students and 16 full-time faculty. And we have active research programs in a variety of areas, including biophysics, nonlinear optics, condensed matter physics, statistical physics, and astrophysics. And we're now home to a new quantum information science program. And we currently have 7 faculty involved, and that's growing. So we have new faculty hires planned in the near future. And we have this brand new Master of Science degree in quantum computing, which just recently got approved. And our first class of students will be starting next fall, in the fall of 2021. So one of the goals of this program is to prepare students once they graduate for the quantum workforce, which is essentially a need that the U.S. National Quantum Initiative has identified as a major need. And one part of that is this emerging quantum industry. And if you look at a survey of the companies and the degrees that their employees hold, vast majority of them are in physics. And so this is essentially natural because physics is where this field really originated, where it grew. And it's a logical home for that. And so that's the case at URI as well. So the quantum workforce is essentially targeting, developing, getting people ready for basic areas in quantum information science, including quantum computing and algorithms, quantum networking and communication, which essentially is applying entanglement and things like that, and quantum sensing and metrology, which includes quantum measurement applications. So a lot of skills are basic fundamental physics skills that includes quantum mechanics and superposition, things like superposition, entanglement, the Schrodinger equation, time evolution under Hamiltonian, as well as some specific advanced quantum mechanics topics, including open system dynamics. So that means evolution under the influence of the environment, noise models, physical noise models that are used to describe that interaction, decoherence, and the basic fundamental principles underlying how this different quantum hardware platforms work. And so those are some, basic physics skills. There are also some more general skills that are also connected to computer science and math, things like quantum circuits and algorithms, error correction, statistics, data analysis. So these are all more interdisciplinary, more general skills, but they also have a strong root in physics. So that's makes it interdisciplinary as well as having a strong basis in physics. And so our master's degree in quantum computing is essentially designed to take advantage of that interdisciplinary nature. So it builds on the physics department strengths that exist currently in quantum information science, optics, and nanophysics. And it's an interdisciplinary curriculum, as I said, so it enables connections across departments, including mathematics, computer science, chemistry, engineering. And it's really designed to be collaborative and to give that opportunity to the students. And so we really want to prepare the graduates of the program to become productive members of the quantum workforce. And so the idea is to give them the ability to engage in developing these unique capabilities of quantum computing that are promised, and so to be able to realize transformative technologies and generate new knowledge. That's really the promise of this field. And so one way we're doing that is that we are partnering with industry as well as national labs and institutes, as well as collaborating with other universities to make sure that our graduates have that required foundation for whatever they want to pursue after that, whether that be employment or future studies like the PhD. And so this is a really rapidly advancing field. So this kind of partnering will allow us to give the students access to the latest developments as the field keeps growing. And so specifically, we have strong support from a quantum computing startup, Zapata Computing, in Cambridge, Massachusetts. And specifically, we have a connection with the founder and CEO, Christopher Savoy. And we also have a variety of collaborative research projects that are possible with various institutions, national labs, other universities, through the faculty. And we're also, our location makes us close to other QIS programs in on the East Coast, including Harvard, MIT, and the DC area. And so we have that location as well. So that really helps in growing this program. So we have a few required and recommended courses in a few different areas. That includes physics, things like quantum mechanics, condensed matter, statistical physics, E&M, math methods, and a research project that allows students to actually do research in whatever topic they want with a faculty member. And we also have math courses that are required, including matrix analysis, linear algebra, and optional courses, things like functions of a complex variable. And there are some courses that are also cross-listed with computer science, so we have that connection as well. And we have new specific quantum computing courses, including introductory quantum computing, advanced quantum computing, and a quantum computing internship. And that actually allows students hands-on experience. So this program is essentially envisioned as a 5-year program. And so by the end of it, you would get a BS degree in physics as well as an MS in quantum computing. And so the MS program is essentially a 2-year non-thesis program. And we estimate about 38 credits for that program. And it's so in the 4th and 5th years of the program. And it has one summer internship, which is in the summer in between the 4th and 5th years. And so you have the basic specific quantum computing courses, as well as the physics courses, the core physics courses, and math courses. And so these are different options that you can take. Not all of these are required courses. And depending on the background of and interest of the student, there are a variety of different options. There are multiple ways you can actually approach this program. So the idea here is to be flexible, and so we have the flexibility to tailor it to the student's specific needs and interests. And this is just a preliminary program, but it's evolving, and I'm sure it'll evolve over time depending on the needs and interests. And so a bit more about the different courses. So the introductory quantum computing course, Physics 575, is essentially an introduction to basic concepts that you need for quantum computing. including, qubits, their physical realization, quantum gates, circuits, algorithms, quantum information theory, and some basics of different physical implementations. And then you also have advanced quantum computing after that, and that gets into more advanced topics, state-of-the-art topics that are, include advanced quantum circuit theory, teleportation, cryptography, and more state-of-the-art frontiers of what's really going on with the physical realizations and quantum hardware. So the latest developments there. And then we finally have this quantum computing internship. So as I said, this is essentially hands-on experience for students in quantum information science. So the idea is that the students would work with a supervisor that they choose either in industry or a government lab or a university. And together with their supervisor, they develop a set of objectives and a statement of work that's mutually acceptable to the student, the supervisor, and the program director. And the idea is really that they can do it with anybody, so with any institution or organization. And there are a variety of projects possible, depending on the interests of the students and the expertise of the supervisors. So there are really a lot of options there, and that's really to get hands-on experience in a specific area. So that's essentially what I wanted to say. So it's essentially, I hope this gives you an idea of, our new program and what it's about. So as we know that quantum information science is really an evolving field and it requires lifelong learning. And the idea with our program is that we want to have the flexibility. We have that flexibility to really tailor it to the student backgrounds and their interests. And our main goal is to provide this strong foundation for whatever they want to do and be successful in that in the quantum workforce once they graduate. So for more information, you're welcome to contact myself as a program director, or Leonard Kahn, our department chair, if you have any questions or want more information on this. And if you are interested and you want to apply, we have a link to the graduate school application site right there. And so please apply and please contact us with any questions. And thank you very much for listening. And both Len and I are happy to take questions at this point.
There we go. There we go. I was having local issues on. I can't talk. I can't talk. I don't know. Thank you, Vanita. Questions from anybody out there in future master students land? The microphones are open if you'd like. Well, Vanita, I have one. So this is it's a new program. It's clearly have some investment from the top down. You're hiring faculty already, et cetera, et cetera. So, a lot of things are obviously not sorted out. Well, not obviously, but by default are yet to be determined as you sort things out. Which I think is a terrific opportunity for a student, because you can help, the process of developing the program based on your interest. I'm sure there's some flexibility built in and so on, but it's definitely has significant industry ties. So, we don't want to take it any further than what that might mean. But what do you think is one of the biggest strengths, if you were to, this is like an interview question, what do you think is the main reason RI's program might stick out to a student potential student at this point? What do you think that is? One bullet point.
So I think it's mainly, like I said, it's the flexibility and proximity to other programs. So it's basically we have the ability to sort of, for students who come in with different backgrounds, whether it's computer science or, mathematics or physics, we can actually adjust the curriculum to suit their needs, essentially. So, we can get people into the quantum computing field that way, depending on, to cater to very different backgrounds. So I don't know if Leonard wants to add something there, welcome to.
I think that is clearly our greatest strength, but we also have connections with a variety of different startups as well as national labs.
Right.
And we already have had, prior to this starting clearly, students who have done projects here on super dense coding and other things like that, partner with national labs and go on to do work there. So we built this program because we had a foundation of success with this, with quantum information, and we wanted to build on this. And I think with this, we've now made it so that we have a core set of courses and these new courses that we've set up that will enable students to do anything from do algorithmic type things to designing different types of gates to doing foundational research in quantum mechanics. And so we want to give students that opportunity. So this is not a technical degree where you learn how to program in Python and be able to set these things up. You can do that, or you can do a variety of other things. So we're not limiting the students by that. And I think Vanita's been rather humble. I think she's our biggest asset that we have because her strength has come from a variety, her pedigree, if you will, has gone through a variety of different places where she has shown how much she can bring to this field. And so we're looking forward to having her lead our program as we go forward.
Yeah, so definitely connections that I have, and I think that would be great to bring to the students. So.
Well, one thing I observed, and correct me if I'm off in it, but it's kind of consistent with what Len just referred to anyway, is notice that the program is called QIS, Quantum Information Science. And to me, that suggests it is a broader, right up there, those first three bullet points. I think you had quantum computing, you had, the other sensing, and so on, which I think is, particularly telling. That does allow for flexibility, vis-a-vis the other programs we've been visiting are very much engineering oriented, and this RI looks to be that next stage, if you will, where you're not quite, correct me if I'm wrong here, but you're not quite you're not engineering necessarily. You're kind of like a little higher up the stack, if I can say that. Would that be a way to think about it?
I think it's both levels. So it's, if you want to go that route, there's the opportunity to do that. If you want to do more, physical hardware, that's more actually my background. So, for projects, I do theory, but I also, do theory that's related to the hardware. And so you have both opportunities there, depending on what you want to do.
Yeah, it is early days there, so you could help craft the program, help develop the program towards what your focus are. This is another thing I observed too, and I'm hoping we get some questions from others. But this is an example of a program that is created really from the top down with some bottom up. And what I mean is the administration has, from what I understand, has really is part of the creation, the birth of this program. Whereas in many of the other programs I've noticed, it's a professor or two or a group of professors getting together and kind of building it up from the ground, the idea from the ground up. Here, I think it's coming from both sides, both end, top and bottom, which suggests to me that, the university as a whole is serious about this program. You got 7 new hires already, and Vanita, I believe you're new on board as well. So if I may, I think that says a lot to, the resources will be there to be made successful, and from the top and the bottom. I think that's an important point, particularly when it's a new program.
Right. Yeah, and I think that's true. We have both old and new faculty in those 7, members. So there's interest across the spectrum, and we have a lot of interest and support from the dean of the College of Arts and Sciences. So we, like you said, we really do have a lot of enthusiasm and support for the program as a, sort of a springboard to a lot of new things at the university itself. And so that's great to have, and I'm really excited about that.
That will show itself in many different ways that you may not initially perceive. I can appreciate, our program here is, by comparison, is just, it's from the bottom up. I'm still working on trying to get the top down buy-in on quantum and all that. And you guys are, I think, pretty uniquely coming at it from top and bottom, which is, that's a good thing. That's a very good thing. Okay. Anybody else out there?
So I see a question. Yeah.
I'm having trouble with my local system here, so I'm not seeing chats. But
okay,
go ahead, please.
So does the university provide any scholarship for the students? So the answer is yes. For qualified students, there is some assistantship available. And Leonard, if you wanted to make a comment on that.
Sure. For those students that are well prepared, we'll offer an assistantship, which is a tuition remission, and it includes also a $20,000 per academic year stipend. And to that, we usually add a few $1,000s for summer research. I also see the question, why do we focus on an internship rather than a master's thesis? We have the internship in that summer between the 2 years. Following that, we have the course that you may have noticed but not paid attention to. The Physics 591 runs a year, and that is a research year so after you finish your summer internship, you can continue that work or branch from that and go ahead and do your own research, following which we have a conference that we hold for all of our master's students and all of our senior students, actually, where they present their research in posters and it's open to the university that comes through and looks at their presentations and a written paper. The dissertation or a master's thesis, we hesitated on that because our university, there's a variety of hoops you have to jump through in order to do a thesis. You may have a paper or 2 that get published, but to get the thesis, there's formatting and everything else. And we thought that in the 2-year span, that takes up too much time from the actual research. So we decided to go with a research project and papers rather than doing that. In terms of quantum hardware technology, we don't have any quantum computers on campus. However, the state of Rhode Island has a Quantum Entanglement Institute, which is just across the bay. If you noticed when Vanita put up the view of the campus, off in the distance was the bay and the Atlantic Ocean. So we're about 5 miles from the bay, and so just across the bay in Newport is a Quantum Entanglement Institute where they do have money to purchase these computers. They're just starting up, and we're partnering with them to be able to take advantage of the proximity of those computers to be able to have our students work hands-on on some of those devices. The state is behind that program, and they are, as we are, in the infancy of this, and they'll be starting up in the next year or so, where they'll have some equipment for us and our students to use.
Yeah, and I think in terms of, if the question was more on what kind of quantum hardware or technology you're interested in working with, I think there are a lot of options there depending on what you want to do. So my specialization is in semiconductor qubits and hybrid qubits that involve superconducting resonators. And so it's theoretical, but I work with experimentalists who do have those devices. And so if you're interested in exploring something like that, feel free to contact me. So there's a lot of possibility for connection with experimental groups working on different hardware, quantum hardware platforms, if that's your interest. So it's just another comment I wanted to make.
Okay, well, I think any other last minute questions before we move on? All right. Well,
Thank
Vanita,
you,
thank you,
Thank
Len,
you,
and
Carol.
Vanita.
Thank you all.
Much luck or much success in your program.
Thank you.
It's an exciting journey, for a program to get started. So
Yeah, we're excited.
yeah, a lot of goodness will come out of this. Okay.